Hey everybody, this is Chris Kresser. Welcome to another episode of Revolution Health Radio. This week, I'm really excited to welcome Lucy Mailing as my guest. Lucy's a fourth-year MD PhD student in nutritional sciences at the University of Illinois at Urbana-Champaign. Her research focuses on understanding how diet and exercise can be used to modulate the gut microbiome and gut barrier function in states of health and disease. She was recently named an emerging leader in nutritional sciences by the American Society for Nutrition and has authored several peer-reviewed journal articles related to the gut microbiome and health. Lucy is also a staff research associate for Kresser Institute and writes about integrative gut and skin health on her blog at ngmedicine.com. So Lucy's been with me for several years now as a research assistant. She has a phenomenal grasp of the scientific literature, particularly related to the microbiome and its connection with health and disease. And some of you may have seen some of the news stories recently on two recent studies that were done that cast doubt on the idea that we should be taking probiotics after we take a course of antibiotics. This is, of course, a very surprising finding and contradicts a lot of what we previously believed about probiotics and antibiotics. So I wanted to invite Lucy on to discuss this important finding and what it might mean for all of us. So let's dive in and see what Lucy has to say about these two studies. Hey everybody, Chris Kresser here. I hope this podcast and my blog and books have been helpful resources for you and will continue to be. But if you've been struggling with a chronic health problem and are feeling stuck, consider coming to work with my team and me at the California Center for Functional Medicine. We work with patients all over the U.S. and have experience treating a wide range of conditions, including GI problems, autoimmunity, hypothyroidism, cognitive mood and behavioral issues, weight gain and metabolic dysfunction, and more. Our unique model teams clinicians with nurse practitioners and health coaches, all of whom are trained in my ADAPT framework approach to provide a high level of care to our patients. This means more support between appointments, personalized guidance on diet, lifestyle, and behavior change, a cutting-edge patient portal with 24/7 access to your labs and records, handouts and resources to guide your protocols, and a team of practitioners working together on your case. We're currently accepting new patients, so if you'd like to learn more, visit chriskresser.com/become-a-patient. Lucy, thanks so much for joining me.
Yeah, thanks for having me on.
So this was kind of a big bombshell that was dropped, this study we're going to be talking about today. And I'm excited that you've been able to join us because, every so often in science and research, we get a finding that completely contradicts what we thought before. And this is, of course, vital to science. This is part of the scientific method that we continually challenge our hypotheses and try to falsify them. And, if you were to ask the average person on the street, I think, should you take probiotics after you take antibiotics? And the average physician and the average researcher, the answer would probably almost universally be yes. But this study suggests that the answer may be no.
Yeah, I think you really have to be willing to put your bias aside here, and we have to go where the evidence takes us. And sometimes that results in a total paradigm shift and directly contradicts what we thought before, like you said. But I think we need to be open to that and especially be honest about it with those who trust us for health information. And so
yes,
I think this
of course, was a big a big topic on my recent appearance on the Joe Rogan debate, where the evidence over many years on saturated fat and cholesterol and their relationship with heart disease changed to the point where even the dietary guidelines in the US and other countries evolved. And yet there's still a pretty committed group of people that is not willing to question those original hypotheses that were developed in the 50s and 60s. So let's maybe not make that same mistake in the case of probiotics.
Yeah, absolutely.
So why don't we start with just some general information about this study. You wrote an article for a website that we published. It's called "Are Probiotics Useless? A Microbiome Researcher's Perspective." And we'll link to that in the show notes. And some folks may have already read it. But for those who haven't, why don't you run us through this study? What were the researchers trying to find? How was it designed? And what were the findings? And then we'll talk a little bit more about what to make of all that.
Yeah, absolutely. So For starters, I think it's important to go over a little gut anatomy, just in case your listeners aren't familiar. So we can think of the GI tract as a hollow tube, and all of the inside walls of that tube are coated with like this thick protective gel. And so in this analogy, the gel represents the gut mucus layer, and the very inner center of that tube represents the gut lumen. And each of these regions has a distinct community of microbes, but these are rarely studied because these regions are rather inaccessible unless you undergo invasive endoscopy. And then, of course, we have the stool microbiome, which is the most widely used.
Let me just interrupt you, Lucy, because some folks might not know what that means. So that basically means a tube being put down your throat to look in your intestine, and not very practical on a broad scale to do that kind of testing to assess microbiome health.
Right. And then, of course, we have the stool microbiome, which is the most widely used proxy marker for the gut microbiome. And you'll often even hear these used interchangeably, the stool microbiome and the gut microbiome. But the first thing that was interesting about this study, before they got really into the probiotics, was showing that, confirming previous findings, that the stool microbiome is really not representative of the gut luminal or gut mucosal microbiome.
That's such an important finding that you said has already been known for some time, but I just want to clarify this for folks. What you see in your poop is not necessarily what's in the gut lumen, is what Lucy was saying, and that presents a challenge, doesn't it?
Absolutely, yeah, and also not representative of what's most closely associated to the gut epithelium in the gut mucus layer as well, and those might have the most impact on our health because they're so closely associated with the actual gut tissue.
Right, and so all these studies that have been done, which are very useful and important, that have correlated the changes in the gut microbiome to health and disease states, have been perhaps only seeing part of the picture, is really what we're learning. And that there may be a whole nother side. Well, there almost certainly is a whole nother side to this story that we don't know very much about yet. It's almost like, the ocean covers 2/3 of the Earth's surface, and we know quite a bit about what's happening up near the surface, but we know almost nothing about what's going on down in the depths. And in some ways, we know more about space off of the surface of our planet than we know about the deep oceans. And I wonder if that's an apt analogy for the microbiome.
Yeah, I think so. They even showed that, if they look at the total genetic information in the gut, so the metagenome, as it's called, there was only a 20% correlation between the stool microbiome and the gut mucosal microbiome. So we really can't necessarily use the stool samples to predict what is actually going on inside the gut.
That's, again, another important point, and it's one that's been so frustrating for me as a clinician, and I'm sure for you too, Lucy. That's what we have access to as practitioners, is stool testing.
Right.
And of course, there's a big variation in the quality of stool testing that's available. Some are better than others, and then stool testing can still be very helpful for things like identifying pathogens. Like, for example, I got recently caught up in an outbreak of cyclospora in the Bay Area here, which some folks on my staff know, but some listeners may not. And it's a parasite. It's an acute pathogenic organism. I also had, in that same food poisoning episode, I contracted enteropathogenic E. coli. And so stool testing can be really helpful for finding, I did some testing and I identified those pathogens and I was able to treat them. So it's really helpful for that kind of thing. But what you're saying is for identifying, what the presence of good, I'm doing air quotes here, good versus bad bacteria and the overall microbiome, stool testing may not be able to tell us all that much.
Yeah, absolutely. I think you said it really well there. It's definitely still useful for identifying pathogens, but any bacterial abundance I get, whether it's from a comprehensive stool analysis, Ubiome, Thrive, I'm always taking that with a huge grain of salt now because, it's really not necessarily representative of what's happening in the gut environment. And so, stool testing can be one piece of the puzzle, but we kind of need a consortium of tests to get a better idea of the total gut environment.
Right. So another thing this study found, which we've talked about before on my blog and in the podcast, is that when you take probiotics, the effect that they have is transient. I think there's been this notion that I refer to it as like a gas tank analogy, where if your tank is empty, like you don't have much good bacteria, and then you take probiotics, you're kind of like filling up the tank. And then once the tank is full, you can stop. But that's not really how it works, is it?
No, definitely not. I mean, And this is not a new finding, but of course it sent the media crazy
Right.
all over again.
Probiotics are useless, right? And
yeah, exactly.
yeah.
Yet we have, hundreds of randomized placebo-controlled trials in humans that have shown, safety and efficacy of many different probiotic strains. So to just outright those media headlines saying probiotics are useless, that may be true of some probiotics, but there's certainly many probiotics that have been shown in randomized controlled trials to have beneficial effects.
But this is saying is they're useful in a different way than we thought before, and that maybe many people still think, right? So instead of working on that gas tank analogy where you're filling up your tank with good bacteria, how are they actually benefiting us as they transit through the GI tract?
Yeah, so they found that there wasn't really significant colonization. They did this in both mice and humans, so there wasn't any significant colonization in mice. In humans, it was very individual. So some people did have some colonization, and those people they term permissive colonizers, and other people were completely resistant to the probiotic colonization. And so, but it didn't really matter because when they lumped them all together and looked overall, there were significant changes in the gene expression in the small intestine in those that were taking the probiotic. So this is in alignment with many studies we've seen before where probiotics don't necessarily colonize the gut, but they're having really beneficial effects in transit, including modifying gene expression, aiding in digestion, lots of these different things, stimulating the immune system. And so, just because they don't colonize, in this case, in some humans they did, but even if they don't colonize, they're still having benefits.
They're still doing a lot of good. And that's why I've often told my patients to think of them almost like immune regulators or balancers because of the impact that they have there. And I mean, in some way that makes sense because historically, a lot of our exposure to these kinds of organisms came through food, and so eating those foods was something that we would do on a regular basis, not just a few times until we got what we needed. We had this kind of ongoing exposure to these organisms.
Right, yeah.
So another interesting finding, which again was not necessarily new, but I think is something that surprises people, is that our normal microbiome kind of wants to stay the way it is and isn't easily changed. So tell us a little bit more about what they found here.
Yeah, so they did a really cool experiment in mice where they used germ-free mice, which are basically raised in a sterile incubator with no exposure to microbes, basically in a giant bubble. And so they gave these sterile mice the same 11-strain probiotic, and they found that in the absence of a normal microbiome, the germ-free mice had massive colonization of the probiotic strains. So this suggested to them that it was the commensal microbiome, the normal gut microbiome, that was inhibiting the colonization of the probiotic strains.
And that's interesting too, in light of the way that human microbiome colonization happens, right? I think we used to think that a baby's gut was completely sterile when they're born. Now I think we know that that's not the case, and there may be some colonizations that happens in utero.
Yeah, I think it's still controversial.
Controversial.
Yeah,
okay. But anyways, it's not, even if there is some colonization, it's extremely minimal, right? It's not like the baby is not born with a fully colonized gut, and that doesn't even happen until later in childhood. So this seems to mimic what we understand about how the human gut develops, is that colonization happens early in life, and that's why exposure to the right organisms is, through breastfeeding and vaginal birth is so important.
Yeah, absolutely.
So another finding you talked about is that the probiotic colonization in humans is individualized. So you mentioned this in the context of some people they had a permissive microbiome, so they were more likely to experience colonization. But that wasn't the only individual difference. What else happened there? Study. I think it was not all of the probiotics colonized equally, or
correct. Yeah. Right. So they looked and they found 9 of the 11 strains colonized.
Yeah.
Significantly enriched in the mucosa, especially. But there was, some people who had significant enrichment and some people who really didn't have any. And that was where they made the distinction between the permissive colonizers and the resistant colonizers. And they did look into some different factors that might explain the permissive or resistant, but they really had a fairly small sample size there, so they weren't really able to tease out anything, although it looked like the baseline microbiome, certain characteristics of the baseline microbiome were able to predict whether they'd be permissive or resistant.
Right. But again, this, as you pointed out, this doesn't mean the probiotics didn't have an effect. I want to read a part of the paper that you highlighted. Nonetheless, when all probiotic consumers were considered together, probiotic consumption led to transcriptional changes in the ileum, with 19 downregulated and 194 upregulated genes noted, many of which related to the immune system, including B cells. So we're seeing changes in gene expression and immune function, even though there isn't colonization.
Yep. And it did colonize in some people, which was contrary to what we probably thought before.
Right. So now we're getting into some of the really surprising, perhaps, parts of the paper, which is that probiotics may slow recovery of the normal microbiome after antibiotics. And I think this is the most surprising part of the paper, and the part of it that conflicts most with maybe what was known before. So tell us a little bit more about that.
Yeah, so like you said earlier, probiotics are widely used and prescribed during or after antibiotics, often, suggested by the physician, with this idea that flooding the system with quote unquote good bacteria can help prevent some of these adverse effects of antibiotics. And so in this study, they wanted to see how taking probiotics after antibiotics impacted the long-term trajectory of the gut ecosystem. And so what they did first, they treated a group of mice. They did this in mice and humans again. So a group of mice and a cohort of healthy human volunteers with a single course of the broad-spectrum antibiotics, ciprofloxacin and metronidazole. And that was just to kind of wipe out the gut
carpet
microbiome.
Bomb.
Yep, exactly. And both of those antibiotics have been shown to have widespread devastation of the gut ecosystem.
Yeah, those are the two worst I can think of, cipro and flagyl. Okay. Yeah. So, okay, continue, please.
Yeah. So then they split the mice and the humans into 3 groups. So group 1 was just allowed to spontaneously recover over time. Group 2 was supplemented with the same 11-strain probiotic that they used in the first paper for 4 weeks, beginning right at the end of the antibiotic treatment. And then group 3 underwent what's called autologous fecal microbiota transplant, or AFMT. And that one's a mouthful, and I think we'll come back to that group in a second. We'll kind of focus on group 1 and 2 at first.
Such a well-designed study, and I love the autologous FMT part of it. I think that was really smart way to do it. Why don't we just go ahead and explain what that is? It means that they took a sample of the microbiome prior to the intervention, and then they put that back using a fecal transplant after. So it wasn't a fecal transplant using another donor's stool. It was a fecal transplant using the own individual's stool.
Yep.
All right. So what happened? We got these 3 groups. What were the results?
So most interestingly, they found that treating the gut with probiotics delayed the return of the normal microbiota for as long as 5 months after stopping probiotic treatment. And
what have you made of this and other people in the field? Like, what's the chatter? I know you work in a microbiome lab. I imagine this was kind of like a big day for all of you, and a lot of discussion amongst your colleagues about this. So what do you make of it?
Yeah, I mean, to be honest, when I saw the headlines and I dove into this paper, or these 2 papers, I was prepared to say, there's got to be something wrong with the methods here. Like, probiotics have to be good. We've known they're good for so long. And so, but I really tried to put my bias aside and really look at it very critically. And I just couldn't get over this probiotic treatment. And microbial diversity remained low for that 5 months as well. It was significantly lower at that 5-month time point. Mm-hmm. Even lower than the spontaneous recovery, which, the spontaneous recovery group had no major differences in the stool microbiome within 21 days post-antibiotics.
Well, that's the part of it that I'm still not clear on, because I know previous work has shown that, and I haven't looked closely at these studies, so maybe there were methodological issues with these studies, but that a single course of antibiotics can alter the gut microbiome for up to 2 years or even longer. So it seems like they didn't find that in this case. And in fact, with no intervention, I think you just mentioned it was about 5 months that they went back to normal. Is that right?
Yeah, so I'm familiar with the studies you're referring to, the previous studies, and that was with ciprofloxacin as well. In those studies, they found that it closely resembled the pre-treatment composition fairly quickly in terms of overall composition of the microbiome. There were a few taxa that failed to recover within 6 months or 2 years.
I see.
So those previous studies, we're still seeing, the microbiome is still very resilient. And so we're still seeing this bounce back. We might be missing a few taxa, but we're not, preventing the return of the bulk of the normal microbiota for more than 5 months.
So has there been any speculation on what the mechanism is in terms of the probiotic inhibiting the natural recovery of the microbiome?
Yeah, so they did a really cool follow-up study to this where they essentially took the probiotic pill and they cultured it in a bunch of different growth conditions that each supported the growth of each of there were 4 different genera in the 11 strain probiotic. And so they cultured it in such a way that one of the cultures had a lot of lactobacillus and one of them had a lot of bifidobacterium. And so after 24 hours of culture, they collected the supernatants, or the kind of the soups that are surrounding the probiotics on the dish.
Mm-hmm.
And then they took that and they kind of added it to a vat of a culture of human fecal microbiota. And they found that the soups, if you will, that had come from the plate with lactobacillus, with a lot of lactobacillus, showed the strongest inhibition of the native human microbiome. So this kind of points to lactobacillus in particular might be preventing this recovery. Right. So, and I mean, that's probably the most commonly used one, Lactobacillus acidophilus. Yeah.
Absolutely. Yeah. I mean, it would be really interesting to see what the differential effects of different categories of probiotics would have in future studies. Like, I wonder about soil-based organisms, or, something like E. coli Nissl, like what, or even beneficial yeast like Saccharomyces boulardii, which some people are often advised to take after antibiotics. Of course, we don't know the answer, but I hope that future studies will be done to assess that. And then I also even wonder about different delivery systems, because there are now companies that are like Seed, for example, and others that have developed patented delivery systems, which they claim make the probiotics more likely to survive the digestive, acidic stomach and upper part of the small intestine. And I wonder if there's a different effect there versus just a probiotic that doesn't have that kind of delivery system. So this study definitely raised even more questions than it answered, I think.
Yeah, definitely. And the other thing to point out is, this was a single combination of antibiotics, probably right. the most devastating of the broad spectrum antibiotics, arguably. Right. And, a single, like you said, a single oral probiotic supplement mixture. So there's so many different combinations of, antibiotics, probiotics, and even treatment timing. So in this study, they didn't begin the probiotics until after the antibiotic course was over. But there's some studies to suggest that if you begin the probiotics earlier, we don't know anything about how it affects the microbiome, but it certainly can be better at preventing antibiotic-associated diarrhea and Clostridium difficile infection.
Right. And they didn't measure any clinical symptoms either during or after the antibiotic treatment, which would have been interesting to see if the changes are in the microbiome or the lack of changes correlated with any clinical symptoms.
Right. Yep.
And I think you pointed out that it would have been also interesting to see, one of the reasons that's often offered for taking probiotics after antibiotics is as a way of protecting against any kind of opportunistic pathogens, right? Mm-hmm. Enteropathogens like salmonella, but we don't know whether maybe the probiotics would have protected against that even though they delayed recovery. So that might be another interesting study to see in the future.
Right. Yeah. And I did dive into the literature a little bit on this to see, what's the degree of the protective effect of probiotics after antibiotics for clinical symptoms or C. diff infection. And there are several meta-analyses But there's a statistical concept that I think you've talked about before on your podcast or your blog. It's called the number needed to treat.
Mm-hmm.
And that's essentially a measure of the impact or efficacy of a particular therapy relative to the burden of treatment. And so in this case, based on the most recent meta-analyses, you'd need to treat 13 patients with probiotics to prevent 1 case of antibiotic-associated diarrhea, and at least 43 patients to prevent 1 case of C. diff.
Mm.
And so in all those other patients, we're potentially delaying restoration of the gut microbiome.
Right.
And so there's definitely this trade-off here.
Yeah. Yeah, especially with the 43. I mean, 13 is a little more of a gray area in my mind, but for 43, that starts to be, the calculus is pretty clear there. Although, it may depend on the virulence of the pathogen. Like with C. diff, there, some 30,000 people, I think, are still dying of that in the US each year. So tricky, very tricky. Let's talk a little bit more about the autologous FMT, because I thought that was one of the most clever parts of the study, and it's certainly something that I think has a lot of potential in the future. I'm personally a lot less enamored with FMT than I was maybe 5 years ago as a potential treatment. Certainly, I think it still can be life-saving in the case of recalcitrant C. diff, where someone has failed antibiotics and they could die. In that case, I think an FMT is a no-brainer, and the research is still really solid on that. But what I've seen clinically is, a lot of people have come to think that FMT is some kind of miracle cure for all kinds of conditions like fibromyalgia, or even, being overweight and autoimmune disease, et cetera. And I've seen definitely some improvement when people have done FMT, and I've also seen no change, and I've seen people get worse. And I'm just, if we go back to what you said earlier about how stool testing is not necessarily telling us what's going on in somebody's gut or what's in the stool, like I just don't know that we have the level. I'm not confident enough in stool testing right now to be able to know that we're screening donors properly. And if the stakes are high enough that like you're facing death, then I think that, again, that calculus makes sense. But if it's like, you've got an autoimmune condition, I'm not so sure. So, it seems like autologous FMT, where you replace if there was a time where you were lucky enough to have a bank of stool sample before you were sick, of course, and that's the big challenge here, the question. That makes a lot more sense to me than donor that has not necessarily been screened adequately.
Yeah, absolutely. Certainly we only have this one study to my knowledge, but it certainly seems a lot safer because you're not going to be re-inoculating yourself with anything that wasn't already there before. So
Right. And in this sort of situation, if someone knows they have to take antibiotics for some reason and they were fortunate enough to bank a sample, that's a lot more clear, right? But if someone is trying to use FMT to deal with a chronic condition, it's probably unlikely, at least at this point, that they would have banked a sample. But there's no reason that in the future that couldn't become something that people just do, that becomes part of our sort of, like when you're 17 or 18 and you're healthy, you bank some stool samples. And then, maybe when you're 30 and you develop an autoimmune disease, you could get an autologous FMT with your stool sample from when you were 18. Who knows?
Yeah, definitely. You can definitely imagine this being a part of normal clinical practice in the future. Like if you're undergoing surgery and you have to have prophylactic antibiotics, then, save a stool sample the day before your surgery.
Absolutely.
Get your antibiotics and then you can re-inoculate.
Yeah, that's a perfect example of where that you're going to be taking antibiotics and you can plan in advance, basically. Yeah. Well, this is really fascinating. So let's break this down. I know some people are probably scratching their head right now or just throwing up their hands saying, oh my gosh, should I even listen to anything anyone says anymore? It's just so frustrating and confusing. And I totally understand that. But again, this is how science works. We continue to learn. We continue to challenge our own hypotheses, even the most cherishedly held ones. And it doesn't mean that that process isn't valuable. On the contrary, I think it makes it even more valuable. And over time, if you look at the last 100 years, I think it's clear that what we've learned during that period of time is just enormous. And so it just means that we have to be willing to be flexible, right? And not hold on too tightly to certain beliefs that we may have had.
Right. Yeah.
So why don't you take us through some of the takeaways, in a practical fashion that, what can people take away from these two important studies?
Sure. So first, I just want to make sure we mention that, we described what the autologous FMT is, but it resulted in rapid restoration of the gut ecosystem, even within, as little as a day to 2 days after the first infusion. So that was just dramatic compared to the probiotics and the spontaneous recovery group.
Yes. And I've seen this in patients with C. diff, who were on death's door essentially and couldn't even walk up a flight of stairs because they were so sick, who within a couple of days after an FMT are like running up the stairs and are well. So it is pretty remarkable. When it works, it really works. And this AFMT or autologous FMT may even be better because I think, Lucy, you may agree with this, is like what we're beginning to understand is there's no one healthy microbiome. Mm-hmm. There's probably more like a fingerprint.
Yep.
Where each person has their own healthy microbiome. So it makes so much more sense to replace using your own stool than somebody else's.
Yeah, definitely. There's so much individual variability, but from person to person in their microbiome, that I think this is definitely the ideal choice, is to use a sample from your prior, ideally healthy self.
Great. So, what would you advise people now, given these results? I know this is just one study or two studies actually, but it seems to me that it was very well designed. I've looked through it carefully, and I know you have, and many have as well. And I'm certainly more reluctant to recommend probiotics after antibiotic use on this basis.
Yeah, I think in most cases, this suggests that probiotic use during or after antibiotics may not be worthwhile. I certainly think it has to be a cost-benefit analysis for each individual person. So someone who's, in a hospitalized environment where they have a greater chance of acquiring C. diff is very different from someone taking antibiotics in an outpatient setting.
Right.
And so I don't want to blanket statement, we should never take probiotics during or after antibiotics. But I also think this definitely suggests that caution is warranted.
Yeah, and I mean, another really key aspect of the scientific method is replication. So I'm really would love to see these results replicated by another research group. Not because I think there was anything wrong with the way this study was done, but history is full of examples of really interesting findings that on the surface appeared to be totally credible and legitimate that failed to be replicated in subsequent studies. So I hope that there are other research groups that are working on replicating these findings, and that also we have research groups that are considering some additional studies that would shed light on mechanisms, and also maybe how these results would change if different antibiotics were used or if different probiotic preparations were used, et cetera.
Yeah, you and me both. I'm hopeful that those studies will come in the next few years as well, so that we can have more evidence to be able to give recommendations after antibiotics.
Mm-hmm. Well, great. Thanks so much for joining me. This is, I think, going to be really enlightening for people. And I really appreciate you helping us to work through the studies. There was a lot of information there, a lot to unpack. And your article is fantastic. And I think this podcast will be helpful. So, Lucy, where can people find out more about your work?
So you can find me at ngmedicine.com or on Facebook or Instagram as Next Gen Medicine. And I just wanted to say thanks for having me on. It's been incredible working with you over the past few years. And it was your site originally that put me on this amazing career path and helped me heal my skin from healing my microbiome. And my gut. So certainly hope to continue to work together and expand our knowledge in this area.
Absolutely. It's been a pleasure to have you on board, Lucy. I really appreciate your insight and your keen intellect and your willingness to dive deeply into the research and translate it in a way that people can understand. It's so important to have that ability and that skill in today's world, because as you and I both know, so much of what's reported in the media is just not really worth reading at this point. When it comes to, I really miss those days where we had actual science journalists that were capable of reading a study and with a critical eye and understanding it. But now, unfortunately, we just have, in most cases, there are still a few good ones, but mostly it's just pulling stuff off the wire and not really looking into it, which is so confusing for people, right? It leads to an environment where people are just throwing up their hands and they feel like they've lost complete faith in public health recommendations. But I think now science literacy is increasing, thanks to people like you who are out there translating your knowledge in ways that people can understand. And that, a more scientifically literate public is absolutely a good thing, but with all the challenges that we're facing. So thank you for your important work.
Thank you. And absolutely, your blog's doing the same, increasing scientific literacy. So,
okay, everybody, thanks for listening. Hope this was helpful. Continue to send us your questions at kriskresser.com/podcast question, and we'll talk to you next time. That's the end of this episode of Revolution Health Radio. If you appreciate the show and want to help me create a healthier and happier world, please head over to iTunes and leave us a review. They really do make a difference. If you'd like to ask a question for me to answer on a future episode, you can do that at kriskresser.com/podcast question. You can also leave a suggestion for someone you'd like me to interview there. If you're on social media, you can follow me at twitter.com/kriskresser or facebook.com/kriskresserlac. I post a lot of articles and research that I do throughout the week there that never makes it to the blog or podcast, so it's a great way to stay abreast of the latest developments. Thanks so much for listening. Talk to you next time.